Good afternoon, all. I'm Dr. G. Kumar, Professor of some Department of Agriculture Engineering, Sri Shanmuga College of Engineering and Technology. Today, we are going to discuss about the topic on soil and water conservation measures. So, the soil and is natural resources. To protect the soil, we have to conserve the soil as well as the water. As a soil and water are the natural resources for agriculture. The soil is eroded by both water and wind, so that the soil to be conserved. So how we are going to conserve the soil in three ways. One is called the biological measures, or also known as agronomical measures. The second one is the engineering measures, and the third one is the mechanical measures. So in the biological measures or agronomical measures involved the crop cultivation practices. So the crop cultivation practices itself conserve the both soil as well as water. So this is called biological or agronomical measures of the soil. And the second one is the engineering measures. When the slope is increases, the land slope is increases, we have to consider some engineering designs and practices for conserving the both the soil as well as water. And the mechanical measures, when the slope is still increases, the runoff velocity will also increases. So it definitely spoil the or erodes the soil very easily. So we have to provide some mechanically measure the soil, that we are going to discuss in this class about the what are the biological measures or engineering measures and the mechanical measures are followed for the conserving the soil as well as water. Then when this soil and water is conserved by the techniques are followed, one is called the biological measures, where we are applying our these techniques are involved where the land slope is 0 to 2% of slope, and the slope is increases from 2 to 8%. We are going with the engineering measures, and the slope further increases from 8% to 32% slope. We must go with mechanical measures. So this biological measures is takes by 0 to 2% means when the land slope is um, most probably uniform in land slope. So there is no much more runoff water will transport. So whenever the land slope is increases, the runoff water velocity is also increases. The main concept of the soil erosion, as per the rational formula, Q is equal to CIA divided by 360. So here C is the constant, and I is the intensity of the rainfall, and A is the catchment area. So this I, intensity of the rainfall, will cause major causes for the soil erosion, and when the slope is increases, this runoff velocity also further increases. This is direct proportionality. So automatically the uh, soil erosion is also will increases when the runoff velocity is increases. So these are all based on its land slopes. Okay, so that when the land slope is between 0 to 2%, we just grow the crop or cultivate the crops, and it the cropping cultivation itself, it conserve the soil as well as water. But whereas in the engineering measures, when the soil slope land slope is increases from 2 to 8%, automatically here the runoff velocity is also increases. So the crop cultivation methods cannot be followed here for conserving the soil and water. So that we are going with some engineering design part in the 2 to 8% slope. And the mechanical measure is also takes for increases in the slope. That means 8 to the slope of the land is increases 8 to 32%. Almost it is in hilly areas. So in that 8 to 32%, the slope is increases, and also when the rain occurs, the water runoff water velocity is also increases. So the soil bulk mass of the soil particles will fall down. That is occur due to the increases in slope. So we have to conserve the soil and water in these regions where the 8 to 32% slope occurs. We must go with some mechanical manners. So we have to construct some kind of mechanical structures, so that those structures will be discussed in the next video. Thank you.